highlighters this way. I'm going to use the orange one on the same thing the whole time, and my yellow one on the same thing the whole time. So if you have different colors, that's fine, but I just make sure. So the inscribed angle, I'm always going to have as yellow, and we'll like talk about what this stuff. And by yellow, I mean orange, because obviously that's orange, and I said yellow. And the intercepted arc, I'm going to make yellow. So my angle is orange. All right, so here's what's important. Inscribed angles are formed by two rays that are on the circle. So they touch the side of the circle. So here's my angle. It's angle B. It's on the circle. We talked about central angles a few days ago. And those central angles, you don't have to turn the page, but just to give you a little reminder, these are what central angles look like. They were all in the center of the circle. Inscribed angles are different. The questions that you are given are not going to have like, flashing lights to say, this is an inscribed angle, this is how you do it, or this is a central angle. You have to be able to look at the picture and identify it. So these are the formulas that we're going to use to solve. So it's important to know the word inscribed angle and also the word intercepted arc. The intercepted arc is basically just the arc that's in between the two rays of the angle. That's the intercepted arc. The inscribed angle is the angle that is on the circle. All right, let's come down here. The rest of this page just kind of has like little shortcuts, and then the back page has the example problems. So we have an inscribed quadrilateral here. Inscribed meaning it is like all of the edges, or not the edges, the vertices of this quadrilateral touch the circle. So the angles that are opposite of each other are always going to be supplementary, or, love that, yes. They're always going to add to 180 degrees if they're across from each other. So if this is 98, you take 180, you subtract 98 from it, you can get 82, and this one's going to be 82 degrees. So that's going to come in handy later. We're going to use this to make this a little bit shorter. And then lastly, like an inscribed triangle. We know that a triangle always adds up to 180 degrees. So the angles of a triangle, angle A, B, and C will be at 180 no matter what because it's a triangle. So that would mean that the arcs that they open up to, so if you add this arc plus this arc plus this arc is the whole circle, that's going to be 360 degrees. So we're going to use those two numbers a lot today. We're going to use 180 a lot. We're going to use 360 a lot. Let's go to the next page. All right, so let's go through, let's highlight these things. It says to find LMK. So my angle highlighter is my orange, my arc highlighter is my yellow. And we're going to write something up here at the top of this page. All right, we're given the arc. So we're going to cut that arc in half, and that's going to be the angle that it opens up to. I always kind of think of these as like, they kind of look like snow cones a little bit. You've got the little cup and then the arc that it opens up to, and that's kind of how I remember those. But you take 70, you cut it in half, and you get 35, and that's your answer. Easy. All right, and then for this one, we're trying to find DEF. So it says to find that. So I'm going to start by highlighting DEF. D to E to F. When you're highlighting, make sure you know how to name arcs, because if you highlight the wrong arc, it gets confusing. And then you're going to start at F and figure out, okay, where does F go? It goes here. Start and then go to D. Figure out what angle opens up to this arc. And it's this angle right here, angle N, or angle FND, opens up to that. So if you are given the angle, you're going to take that angle, you're going to multiply by 2, and you're going to get 208 degrees. 208. How do we know how to do that? Because that is the relationship of inscribed angles to the intercepted arc, or the arc it opens up to. That's always going to be the relationship no matter what. Because this inscribed angle is on the side of the circle. You'll see how that's different from the other day where they're in the center of the circle. When they were in the center of the circle, they were the same as the arc they opened up. When they're on the side of the circle, they are half the value of the arc. All right, find the measure of the arc. Remember that the diameter cuts the circle in half. Okay, for this one, I'm going to do my highlighting a little differently, but every problem, you can do it differently. It's just however you would like. Instead of highlighting what it's asking for, I'm actually going to highlight what's given, just because I feel like that helps me to see it better. So here is the angle and the arc that it opens up to. So this is a two-step problem. You have 50 degrees for the angle. You take that angle and you multiply it by 2 to get the arc it opens up to. Great, so we have 100 degrees. You're not done. You can't just say 100 and then move on. What you have to do now is realize that a diameter cuts the circle in half. We talked about this when we talked about central angles. You have a diameter. If you cover up half of that circle, you realize this is 180 degrees. And I have 100 here, but I need to realize that this is 80. Because 180 minus 100 is 80 degrees. And that is how I can solve for this one. So 50 times 2 is 100. It's just, however, if that doesn't make sense to you, it's just 50 times 2. But write it how you know that this turns into 100. All right, and they won't all say this. I just put this in the notes. You're going to have to be able to identify diameters on your own. When you look back in the notes, hopefully this will like jog your memory of what happened. All right, moving on to this one. So there are multiple ways to do this problem. However, I'll show you 2 ways, however you want to do it. One way that you could do this is to start by realizing that like this arc is the one we need. And we have all of the other arcs besides this one that I have highlighted. So what we could do is take 360, which is the entire circle, and subtract the other 2 arcs, which we don't have calculators today, so I'm going to do this on my phone. 96 plus 76 is 172. And then if you do 360 minus 172, you get 188. All right, so this is 188 degrees, this arc out here. And if you take this arc and you cut it in half, you get 94 degrees. This is 94. Okay, that's one way you can do it, but the thing that is nice about circles is it's kind of a puzzle and you can figure out lots of different ways. The other way you could have done this is to realize, oh, we can figure out angle F by taking these 2, so 96 and 76. All right, so we can say, or 96 plus 76 equals 172. And then if you cut 172 in half, what do we get? 172 divided by 2. You get 86. Why are we cutting 72 in half? Well, if this is 72, that means this angle F over here is half, or if it's 172, it's half of that. So that means this is 86. And then on the page before, we talked about the relationship between the opposite angles in an inscribed quadrilateral. They're going to add up to 180. So like 180 minus 86 equals 94. Oh, I can't see that. So that is the second way to solve that problem. You can do it either way. 180 minus 86 equals 94. All right, both of those ways. Okay, different ways to solve these. I'm going to show you one way, and then I'll probably just talk about the other way. One way that you can solve this is realize, okay, another inscribed quadrilateral. That's why we talked about this on the first page, because you will see this often. 100 degrees over here, 80 degrees over here. How did I know that? Because they're going to be supplementary if they are opposite angles and they're inscribed quadrilaterals. 180 minus 100 is 80. Great. Then we have 80. Then we can figure out what this entire arc is by multiplying this by 2. How did I know to multiply it by 2? because we're looking for this piece, so we eventually need to get this arc. And if I have this angle, in order to get the arc, I need to multiply by 2. So 80 times 2 is 160. So this entire yellow arc here is 160. If it helps, like highlight the yellow, like highlight the 160, and maybe you can realize that 160 is that big arc. But we don't need the whole arc. We only need this piece that's highlighted. So I'm going to take away 64 from that, and I think it's 96. But if it's not, let me know. 96. And then the other way you could have done that is take 100, multiply it by 2 to get 200 for this arc. And then subtract 264 from 360. So from here all the way to here is 200, and this is 64. Take all of that away from 360, and you would get the same answer. You'd get 96. So like, really, there's not like a certain way to do every problem, and that's what gets confusing about this, and that's why I'm doing so many examples. Typically I only do like 2 or 3 examples, and you can see how to do it. There are just so many different ways to solve these that it's helpful to see lots of examples. All right, this one. So now we're adding a little bit level of difficulty on here because we have these that are solving for x. So let's highlight. All right, so for the angle, you need to multiply it by 2 to make it equal to the arc. And we wrote that on the page before. We haven't really talked about that a ton, but 2 angles equal 1 arc, or 1 angle equals half an arc. So it's kind of whatever you want to do. Would you, just looking at this, would we prefer to cut this in half, or would we prefer to multiply this by 2? And this is how I look at it. If I look at it and I'm like, I can cut both of those numbers in half without any fractions or decimals, I'm going to do that. But you can't here. I don't want to deal with 5.5 and 2.5, or fractions, 11 halves and 5 halves. So instead, I am going to do angle times 2 equals the arc. All right, so we're going to subtract 8. Well, I distributed, and then subtract 8 on both sides, while also adding 5 on each side. So what is that? 33 equals 3x. That's what I'm getting. Because I did plus 5 and minus 8x. So x is going to be 11 for this one. Just pay attention to if you are needing to plug in and solve for like a particular arc or angle. This one just says solve for x, so no big deal. All right, let's look at this one. Looking at this problem, there's multiple ways to solve it. I think the easiest way is to just take this and multiply it by 2 and make it 12x minus 12. Make sure you distribute and both of the things get multiplied by 2. So once you have 12x minus 12 there, you have all the arcs. All of the arcs equal 360 degrees. So you can just add them all together. So I'm going to add all of my, just my x's together. 18 plus 18 plus 12 is 48. And then negative 7, negative 5, and negative 12 is minus 24. All right, how did I do that? I just added all of these together, combine like terms, and then now I'm going to solve. So 360 plus 24 is 384 divided by 48. But I mean, there are multiple ways to solve this. I guess theoretically you could have subtracted these two from 360 and put it right there, and then, yeah, that just seems really confusing. I think this is by far the easiest way to do it. Yeah.